Hi, I'm Kendall Geisel, and today I will be doing the Half-Life of M&M's hands-on lab. It is the 7th of June. Okay, so the materials are just a plastic container filled with M&M's, and it's approximately 130, over 100 M&M's. So I've put the M&M's in the plastic container and I'll shake it. And then I will carefully pour it out onto the tabletop. Okay, now I'm going to count and record, and I'll get back to you in a minute. Okay, so I added them up, and I had 100 non-decayed M&Ms, which were the ones with M's up, and then I had 82 M's down. So my percent activity is 1.2%. So now I just have the 100 left, and I'll do the same thing. So, okay, for the first half-life, I got 57 non-decayed with the M's up and 43 decayed with the M's down, leaving me with 1.3% activity. Okay, now I have 57 left, and I'm just going to repeat the same thing, and I'll count these up. Okay, for Half-Life 2, I got 29 non-decayed M&Ms and 28 decayed M&Ms, leaving me with a 1.0% activity. And now I'm left with 29 M&Ms. So I'm gonna count these up. Okay, Half-Life 3, I got 8 non-decayed and 21 decayed, leaving me with a 0.38% activity. And so now I have 8 left. I'm gonna keep doing this until there are no more M&Ms. Okay, for Half-Life 4, I got 5 non-decayed M&Ms and 3 decayed, leaving me with a 1.7% activity. So that leaves me with 5 non-decayed. Let's see. Now I have 2 decayed, 3 non-decayed. 2 decayed, 3 non-decayed. Okay. 2 decayed, 1 non-decayed. Okay, let's see what happens. And it's decayed. So that's the end. I'm going to go calculate the percent activities. Okay, just a quick recap. For Half-Life 5, I got a 1.5% activity. For Half-Life 6, I got 0.5 activity. And obviously for the last Half-Life, I got 0% activity. Okay, now the questions. What fraction of the original amount would be remaining after 10 half-lives? I said 0 because there was nothing left after 7 half-lives, so, you know. Number 2, would radioisotopes with long or short half-lives be used in medicine? I said long, so they could last longer and decay slower so that the medicine can be more effective over a longer period of time. Number 3, calculate the amount remaining of 150 grams of a radioisotope with a half-life of 30 minutes after a period of 2 hours. Basically, this is just over 4 half-lives because 30 minutes goes into 2 hours 4 times. And once you calculate that, you get 9.4 grams left. Number 4, radioisotopes used in medicine are stored for a period of 10 half-lives before they are discarded. How much time would have elapsed before disposal of a radioisotope which has a half-life of 30 days? you sort of do this the same way that you did number 3. I got 330 days, just because 30 times 10 is 300, and then you add an extra 30 because the first half-life is considered 0, like in the data table. Number 5, if on September 1st a school purchased a radioisotope of mass 350 grams with a half-life of 45 days, how much of the sample would be left on June 1st? And I calculated that the number of days between September 1st and June 1st was approximately 274. All right, continuing number 5. Then once I found that the number of days between the two dates was 274 days, I halved it until I got to 5.47, which was 270 days away. And then, so I concluded that the ending mass would be 5.4 grams. Okay. Number 6, what description would you give to the relationship between percent activity and number of half-lives? I said exponential. Number 7, why are the M&Ms a good model for radioisotopes in this activity? They're such a good model because they're small, easy to use, and have two sides that are easily distinguished, and it's a 50-50 chance of getting the M or the blank spot. Number 8, other everyday material that could be used in place of the M&Ms is just a coin, because it has the same 50-50 chance of landing on either heads or tails.